Well, hello again. This is an example illustrating the use of the addition rule. Hopefully, up to this point, you've read about the addition rule and noticed that the addition rule basically says, just to refresh us, that if I have two events, say E and F, the probability of E union F is equal to the probability of E plus the probability of F minus the probability of the intersection of E and F. Okay. And we use this rule to get at the union probability, or sometimes we know the union probability and we know these two probabilities here, and we use this rule to find the intersection probability. But in this example here, we're going to use it in a more straightforward sense. And here, what we've got in this example is a box that has 11 large marbles in it. So here's our box. We have 11, I'll say, large marbles and 18 small marbles in it. And then they go on to say that each marble is either green or white. And further, they say that 4 of the large marbles are green and 7 of the small marbles are white. And so I want to incorporate that information. I'm going to kind of re-represent this box of marbles by noticing this first statement that 4 of the large marbles are green. So I'm going to say that 4 are large and green. Let me erase this here. And I'm also, so if 4 are large and green, that means, okay, I've got 11 that are large. That means I've got 7 that are large and the other color, white. Okay. In the same way, I know that 7 of the small marbles are white. So I've got 7 that are small and white. And so if 18 are small, 7 are small and white, that means 11 are small and green. Okay, so I've got that information partitioning out this box in terms of the colors and size of the marbles. Now, if a marble is randomly selected from the box, what is the chance that it is small or green? Okay, so I'm after the probability that it is small or green. So you've kind of picked up on union usually goes along with the or between two events, an inclusive or between two events. And the intersection deals with two events happening at the same time, or what's common between the two events here. And so we're asking the chance that we pull up a marble that's small or green. And the ways that can happen is the marble could be small and white, or it could be small and green, or it could be large and green, or small and green. I think I already said that part. But instead of trying to think about all those different ways and computing those probabilities, we're going to use the addition rule in a straightforward way here. So the addition rule would say the probability of S union G is the probability of S plus the probability of G minus the probability of the intersection here, S intersect G. Okay, so the probability that I get a small marble, well, let's see, I would use this representation of the box to get at that probability. I know that I've got 18 small marbles out of the total of 29 marbles in the box. So that probability is 18 over 29. Plus the probability of a green marble. Well, I don't quite have a setup like this that I did for this probability in order to get this kind of the probability of a green. But if I look at the information I have in this box here, I've got that 4 basically were green and that 11 were green. So that means that there's 15 total green marbles, and again there's 29 total in the box there. So it's 15 over 29 for that probability. Now the probability of the intersection is, let's see if we have that straightforward from our picture. The probability of S intersect G, the probability that we would draw a marble that is small and green. And from this second picture here, we've got that probability, or the number of outcomes in this event rather, so we can get that probability pretty straightforwardly. That's 11 marbles that are small and green out of, again, 29 total marbles. So just doing a little arithmetic here, 18 and 15 is 33 minus 11. That would be 22 out of 29.